So far, we have discussed all the main tools that we can use for the implementation of complex thread synchronization policies. We have seen that we should organize our software with active entities, namely threads, and passive entities, the resources. But we've seen that the code we develop is getting quite complex, and it's necessary to understand how to master this complexity. By understanding that we have active entities and resources, we can start moving in the right direction, but we need more. Well, in this section, we will discuss the monitor. It's a pattern. You can see it as a pattern that can help you organizing your code in a very effective way that makes your code easy to read, to understand, and to manage. So, it's time to get started. The monitor provides a high-level synchronization abstraction to threads. The basic idea is to encapsulate the resources that thread access into the monitor and to provide the thread with programmer-defined operation methods to let the thread interact with the resource. This simplifies in a significant way the implementation of threads. So when you implement a thread, you don't have to mix up its logic with the thread synchronization policy and the access to the resource. It's a very important way, it's a very important approach to software modeling that help us in mastering the complexity of multi-threading programming. In addition, by definition, only one process may be active within the monitor at any time. So no more than one and only one thread can be executing at a given time within the monitor. So what's the idea here? The idea is that when a thread calls some operation, some method of the monitor, it may either have to wait to access the resource, or it may enter into the monitor, and in this case, it's the only entity accessing the resource encapsulated within the monitor. It's the only active entity executing in the monitor. This simplifies a lot the way we want to manage and organize resource access within the monitor. In order to better understand how monitor work, let's consider a simple example. Here is the old code of our example application. Just to give you some idea what we want to do, we simply mean to build a few threads that are accessing a resource, and the resource is encapsulated within the monitor. The monitor basically manages a variable, and the variable is a shared is the shared resource among the threads, and provides very few methods to manage the resource, namely read value, set value, and get value. That's it. So now it's time to understand something more about our code. On the left hand side of this slide, we see the monitor we will build. And the monitor is in charge of managing the resource and the thread synchronization policy. On the right hand side in this slide, we see free function, and this function basically define the business logic of three classes of thread, namely consumer, producer, and reader. That's it. Now, let's analyze with more detail the monitor. This is the monitor class. It is an ordinary Python class, so nothing special. And it's important for us to understand the attribute of this class. We have a mutex, we have a condition variable, and we have the resource. That value attribute represent the variable we manage, the resource that all the threads need to access. Let me stress, then when we define the condition variable, we pass in the mutex, and the same mutex is used to protect all the access to the resource. Why this? Because we want to have a single thread executing into the monitor at any time. So every thread must be waiting on the same lock to be sure that just one of them is into the monitor. Basically, we said it before, when we have the need to guarantee that several threads access it in a different way are synchronized in a proper way, so we have just one of them executing, it's appropriate to reuse the mutex within the condition variable. That's the reason why we can pass in this variable. We have different methods, as you can see here. With the read value method, we use the mutex to guarantee that just one entity is able to access the resource. So the mutex protects the access to the resource, and we can read the value without any interference from others. It's similar for Java programmers to synchronized primitive. So it's very, very similar. Then we have the get value and the set value methods. In this case, we use the condition variable, and in particular, the condition variable makes it possible for us to implement a simple synchronization policy to access the value attribute. In particular, let's consider the set value. We have a condition variable, and if the variable is not known, so if there is some value, we cannot set a new one, and as a consequence we have to wait on the condition variable until somebody consumes the value of the resource. So here we have this condition variable where the thread willing to access the resource may have to wait. Whenever somebody consumes the value, or if we are in the beginning and nobody set this value in the first place, well, we can set up a new value for the resource and notify all other threads that we are done with the use of razors. It's very important, we know, we already said it before, that after using the razors, we notify other threads that we are done with the execution so that they can take advantage of the razors. They can access the monitor in this case. Similar consideration uh, for the get value. Here we have another condition variable, and the logic is quite simple. As long as the value is none, you cannot consume it. So we have a condition variable and a logical condition uh, that makes threads to wait to go sleep in case there's no value to consume. Whenever a another thread concluded its set value and notify everyone. Also, threads willing to consume the value are woken up and they can enter the critical section. They can enter the monitor and they can consume the value, set the attribute to none, so actually consume the value, notify everyone that they are about to leave the monitor because they have already consumed the value, and return it to the calling thread. That's very simple. So let me stress again the way we organize this code. Basically, the code is quite simple. Here, yes, we mix some aspects of razors logic and razors management with the thread synchronization, but in the end, this is an easier way to organize the code, as we are implementing all the razors management logic and all the thread synchronization logic in a defined area, in a dedicated place. This makes the code easier to read. It's easier to maintain if you have some know-how about multi-thread programming. This is a good way to organize your code. In order to better understand the advantages of this approach, it's worth considering the implementation of threads. This is the implementation of the logic of the different threads. So we have three threads: consumer, producer, and reader. Now, producer basically set a new value on the razors. Consumer can consume razors, whereas a reader can simply read razors, but the razors is not consumed. So let's try to understand some important aspects in how to use monitor in multi-thread programming. An important aspect I want to stress is that we pass in the monitor as a parameter because the monitor is a shared razors among all these threads. So we have to pass in as a parameter. It could be also a global variable, yes, but it's very common and approach to pass in as a parameter. So it is some shared entity. If you use the approach of implementing threads as a subclass of the thread class, the monitor could be an attribute of the class. That's the idea. Another important aspect I really mean to stress is that we don't need to implement complex code, complex logic in order to access the resource, but we simply rely on the mediation of the monitor. This makes the implementation of threads straightforward and makes it possible to concentrate the logic of thread synchronization into the monitor. This has several advantages. First of all, code is more readable and easier to maintain. In addition, it could be possible to evolve the representation of a resource. And the resource is the representation, and we can hide the representation of the resource from the implementation of threads. This is a very good approach in organizing our software and makes it possible to guarantee the possibility to evolve it with the time in a easy way. This is an example execution of our application code where we have different threads accessing the monitor, and the important message here is this. The implementation of synchronization mechanism is complex, and we can relay and adopt the monitor pattern to better organize our software. This comes with several advantages, as we can rely on the monitor to mediate the access of threads to resources. This makes it possible to concentrate the thread synchronization logic into a single class, to hide the implementation of the resource, and to simplify, as a result, the maintenance of the software. That's all. So, time for a recap. This is a summary. In this section, we discuss the monitor pattern, and we analyze an example to better understand how the monitor works. The monitor is a construct, is a synchronization abstraction where no more than one thread is executing at a given time. It's a construct where the access to resources is mediated by a method, and where the resource is encapsulated within the monitor. So it's time to move on.